What I'm going to do today is a little review of what you did in geometry. Sine, cosine, tangent, Pythagorean theorem. All right, I want to go over all that stuff again because, yeah, it'll be on the quiz Monday, but also it's a huge part of the second half of this unit after we take the quiz. Pythagorean theorem, you guys know a squared plus b squared equals c squared. Just a reminder, this is huge. It can only be used in what type of triangle? Only for a right triangle. Yep, nothing else. Excuse me. So I just want to go through different ways we're going to use Pythagorean theorem. First one is just your basic one. So go ahead, set up triangle, right triangle ABC. As you read part A, where is your right angle? At C. It does not matter. Does not matter where you put A or B. And then AC is 2, BC is 3. Find AB in simplest radical form. Okay, so it's a right triangle. I have two sides trying to find the third. Pythagorean theorem. I don't know how much of the numbers I'll use today to call on because I know this is probably 2 years ago. Most of you guys did this. What's A, B, C? Where do the 2 and 3 go? 2 and 3? A and B. Those are called, anybody know, by the way, little extra, what those are called on the right triangle? Legs. And the biggest side is the hypotenuse. There you go. So 2 squared plus 3 squared equals C squared. 4 plus 9 equals C squared. C squared equals 13. Still got to do what on both sides? Square root, yep. So C equals the square root of 13. And I did say simplest radical form, but you can't break down 13. There's no perfect square that goes into it. So that's about it. And if I'm going too fast, let me know because I got to go over a couple different concepts here. We all good with that one? All right, you ready to go for Laura in her backyard? Conveniently, it's in the shape of a rectangle for us, huh? And it measures 12 by 15. And she wants to put a rock walkway. How about that one on the diagonal? Diagonal again, you geometry studs? Oh, no. Just where do I put a diagonal? Corner to corner? Okay. Well, if you're going to connect here to here, that's called a side. Right? What else am I going to connect, Brett, other than corner to corner? Bottom to bottom, that's already connected. It's a side. What other angle other than a straight line am I going to connect it with? That's not curved. Okay, all right, I got you there. Got you, yeah. Okay, yep. But no, corner to corner. How long does it have to be? There we go. And I always like to challenge you when I can. You guys said it could only be used for a right triangle. How is this a right triangle? Lily? Say that again? How do you know they're right? How do I know there's a right angle here? Michelle? What type of figure was her backyard? It's a rectangle, right? All the angles in a rectangle. Come on, your geometry days. Right angle? Okay, yep. I'm assuming most of you are in the same boat. That's because you probably didn't come through D238 for geometry school, so that's probably why. You didn't come through this class for geometry. I know you didn't. I didn't have anybody in here, so. 12 squared plus 15 squared equals c squared. Round your answer to the nearest tenth of a foot. $19.2, yep. Okay, any issues there? Using Pythag. One more instance of using Pythag, because we are taking a higher level of algebra right now, so I do want to go over a higher level algebra question using Pythag. Right triangle, what's one leg? What's the length of one leg? X minus 4, so I'm going to write X minus 4 squared. Go ahead, Brett.
So the last problem, we had like a radical, like 1300.
Yep.
That didn't solve out to like an even number.
Okay, that's why I had rounding directions.
Yeah, but why did can't we just leave the 369 under the radical right now?
You could, but what does the direction say? All right, round your answer to the nearest tenth. Got me?
Yeah.
Okay, X minus 4 squared plus what's your other leg? 8 squared equals hypotenuse? X squared. I feel like we've been down this road many, many times together this year with X minus 4 all squared. You are not distributing that too, are we? What's your plan of action? You're better than this. Off to the side, I'm going to do X minus 4 times X minus 4, yes. So I'll let you do that and let me know what you end up with. It looks pretty complicated, but it's not bad. Okay, x squared minus 8x plus 16. That's what we should get when we double distribute FOIL. Any questions where those numbers are coming from? Negative 4x becomes negative 8x. Doesn't cancel out. And then plus 64 equals x squared. I'm interested to see what you're going to do from here. What do you want to do for here? Because remember, I got to solve for x. Rachel, your move?
I added the 16 and the 64.
Oh, okay. Clean it up. All right. Yeah. X squared minus 8x plus 80. All right. I like it. Clean it up. Brett? I could. Yeah, that's fine. And when I do that, what's going to happen? Anybody going to see when I start moving things around? What's gone? The x squareds are going to see ya. So really, if you want to set it equal to 0, Brett, I could say negative 8x plus 80 equals 0. Now that the x squareds cancel, can you guys solve for x now pretty easily? Get x on one side. All right, so go ahead. And what'd you find? X equals 10. Good. Good job. So just a little higher level algebra with Pythag. All right, we okay? All right. Do you remember in your geometry days, and it's okay if you didn't, 45, 45, 90, 30, 60, 90 triangles? Maybe a little bit, because that's what I'm going to review real quick right now. Okay. So you have one type of triangle, which is a 45, 45, 90 triangle, a special right triangle, 45, 45, 90. Do you remember anything? I'll let you guys take it before I give it away. Do you remember anything about the sides of a 45, 45, 90? Sarah, what's up? Yeah, everyone's perfect. I got two 45s, right? The sides across are always the same. Okay, so I'm going to put an X and an X here. They're always the same. The sides across from the 45s are always the same. And then the hypotenuse is going to be ready? One of those sides times radical 2, always. Okay, so those two sides across from the 45s are always the same, and the side across from the 90 is always that side times radical 2. So ready? 6, 6. What would be that side? I got 6, 6, and this would be 6 radical 2. Okay? 10, 10, 10 radical 2. Okay? I just multiply radical 2 by one of those sides. We okay there? Then there's another type, which is called a 30, 60, 90. I'm going to start with the side across from 30 is x. So I know the side across from 30. Go ahead, Brett. Go ahead, try it out. You are correct, sir. Yep. The side across from 60 is going to be that side times a radical 3. And do you remember the hypotenuse? It is 2 times that side across from 30. You remember a little something back in the day, right? So one side is double, the hypotenuse is double the side across from 30. Okay? All right, let's try a couple. And I don't expect you to be great at this, all right? But I think you could be. Right triangle ABC. Where's my right angle? What's it say? Where's my right angle? C. So there's A and B. What's angle A? 30. And the length of BC is 8. Okay, find AB. So first thing, what type of special triangle is this? Out of the two I just put up, this is a 30, 60, 90, right? Where's the 8 across from? The 8 is across from the 30, and I'm asking for the side across from the 90. What was the relationship we talked about between the hypotenuse and the side across from 30? It was just times 2, right? It was double. So in this case, AB will be equal to 16. Yep. Quick. Whoa, whoa. I always want to pressure you. What would the other side be then? AC. Multiply it by, not 2 anymore, but radical 3. So it would be, AC would be 8 radical 3. Okay, if we need to find it. How we doing, all right? Okay, let's keep grinding here. We're working good pace. Okay, ready? Ladder leans up against the wall. That's our classic right triangle diagram. And it leans up against the wall at 45 degrees. Ladder is 12 feet long. What type of triangle am I working with? 45, 45, 90, right? How far up the wall does the ladder reach? Not on the ground, how far it reaches. All right, we're going to be a little tough on this one. Okay, what's the 12 on this diagram? What's the 12? Hypotenuse, right? All good? So I need to go from here, oops, sorry. I need to go from here to here now. So how would I get rid of the radical 2? From here to here, I multiply by radical 2. Everyone agree? If I went from this side to the hypotenuse, I multiply by radical 2. So how do you think I go in reverse? How do you think I go in reverse? Go ahead. Divide by radical 2. So that's what I'm going to do. X is equal to that 12, not times, but divided by radical 2. Oh, make your teacher last year proud now. Cannot have a radical in the denominator, right? Anybody know how you got rid of it last year? Come on, make them proud. Make whoever it was proud. Jenna?
I was just wondering, could you square both sides to get rid of the...
Square both sides?
Yeah.
Now you're going to get x squared now. Right? All right, and I don't want it to keep building up. You're going to make somebody proud here, Michelle? Multiply top and bottom by, yes, no, or did we just miss that day? Multiply top and bottom by radical 2 to get the radical out of there. Can't have a radical in the denominator. We call that having self-respect in here. Never have a radical in the denominator. Don't be an embarrassment. Got it, Brett? Okay. All right, well, how does that help us? Ready? 12 times radical 2 is just 12 radical 2. And then what happens on the bottom? Oh, cancel. What do you mean cancel? What's a radical times itself? Oh, boy. Oh, boy. Radical 2 times radical 2 is just the number underneath, Ashley, which is 2. Yep. Is that what you mean by cancel? Yeah, I don't think so. Because you just thought they wiped out. Yeah. And bad news, there's still one more step here to simplify. What can you still do? Divide 12 by 2 and get final answer of 6 radical 2. Now, I know that was a lot right there to process. So let me give you a quick trick, even though I hate doing this as a math teacher. How do I go from the hypotenuse, in a 45, 45, 90, how do I go from the hypotenuse to a leg real quick without doing all this mumbo jumbo here? Divide by 2 and put a radical 2 with it. That's all we did, right? Divide by 2 and put a radical 2. Instead of going through all that again, what's each leg going to be? Okay, so I'll save you the aggravation. What's each leg going to be? 2 radical 2. Okay, 45, 45, 90. All good? Questions? All right. You guys are being patient with me today, which I appreciate, especially reviewing all this geometry stuff. All right, and then we got a good problem right here. Can I blow it up? Yep. I'll let you guys label everything that I gave you on top. Okay, so go ahead and label your diagram with all the degree measures. All right, we have to find all the missing sides now. In what order does not matter. But we just got to find all the missing sides now. Do you see any of the special type of triangles we've talked about? Name one of the special types we've talked about up there that's up there. I see a 45, 45, 90. The one to the left, CBD. Yes? All right, so let's focus on that one. The 10's across from what angle? 45. So guess what's going to be across from the other 45? What's going to be across from the other 45? 10. So what side's also equal to 10? DC is 10. Done. All right. Stay in that triangle. What would the hypotenuse be then? Go back, look at your rules if you need to. I got 10, 10, and the hypotenuse would be, according to your rules, 10 times radical 2. Done. So what side is 10 radical 2 up there? What side would be 10 radical 2? D, B would be 10 radical 2. Everyone all right? All right, we didn't find all the sides yet. Is there another? We just took care of the 45, 45, 90. Is there another special triangle up there? Anybody see another special type of triangle? What do you got, Alex? The whole thing, ABC. Everyone see triangle ABC? Do you see how that is a 30, 60, 90? Yes! What's the what side? Oh, watch your mouth here now. Watch your mouth. What side is the 30 across from? In the whole triangle, ABC. What side is 30 across from? BC, which is how much? 10. So I have the side, I erased it. I have the side across from 30. What's the side across from 90? What's the relationship between those two? Go back and look. The side across from 30 and the hypotenuse. What do I have to do with that smaller side to get to the hypotenuse? Times it by 2. So 10 times 2? 20. What side up there is going to be 20? A, B will be 20. And it looks like I'm missing one more side. What side have I not found yet? I got DC, I got DB, I got AB. I need AC now. Whew, all right, no big deal. AC is a part of what triangle? The big one, which we said was what type? 30, 60, 90. Okay. So I already have the 30 here and I have the 90 here. That means this angle up here has got to be the what angle? 60. What do I do with this 10 to get to the side across from 60, according to your rules we wrote earlier? I got the side across from 30. The side across from 30 is 10. You multiply it by what to get to the side across from 60? Radical 3. So my side AC will be 10 radical 3. Whew. Questions? I know that's tough. I get it. I know that's tough. Questions from you guys, though, before we get into the last third of this class. Going. Okay. I'm not going to say anything. Just go ahead and set up triangle ABC. C is the right angle. Can I use Pythagorean theorem here? What? I'm hearing yes. I'm hearing no's. Can. Do you have enough to fill in for a squared, b squared, and c squared without introducing two different variables? No. Okay, so Pythag's out. Is this a special triangle we just talked about? Okay, so we're stuck. Right? Everyone agree? I can't use anything we've used in class so far. So that's with the third and final thing we could use on a right triangle. Sine, cosine, and tangent. Now, this is going to be huge second half of this unit. How do I use this real quick? The S for sine. Don't say sin. Have some respect. All right, not sin, sine. What's sine equal to? Anybody remember what the O was? Opposite side over hypotenuse. Good. C for cosine is equal to adjacent over hypotenuse. And then T, tangent is opposite over. Okay. So we need to figure out which one of those three do I use in problem A. So go from the 37 degrees. Here we go. Is side X opposite hypotenuse or adjacent to the 37? It should be. It's across, right? So it's opposite. I put a little O there for opposite. And how about the 20? That is adjacent. So we have adjacent and opposite in this problem. Look back at SOHCAHTOA. What is attached with the opposite and adjacent side? TOA. T for tangent. So I'm definitely going to use tangent, abbreviated TEAN. So how do we set this up? Tangent of, what was the angle I used? Tangent of 37 equals, ready? Keep following it. Opposite, what do we label as opposite? Over adjacent 20. Only thing I'm going to make sure you are right now, hit your mode button on your calculator. Because 37 is what? Degrees or radians? Degrees, so make sure your calculator's in degrees right now, or we will not be on the same page. How do you want to solve this? How do we solve something like this? Cross multiply. So x equals 20 times tangent of 37, which you can do right on your calculator. So 20 times, everyone sees where the tangent button is. So 20 times the tangent of 37. And I know this is a lot I'm packing into one day. What do we have? Nearest 10th? What do you got for me? 15.1. Yep. Anything there from you guys? Okay. Do you remember this vocabulary, angle of elevation? Okay, angle of elevation. I'm in a right. That tells me I'm in a right triangle. Elevation is you're on the ground looking up at something taller than you. Okay, you're on the ground looking up something that's tall. So you're on the ground looking up at a building. You're on the ground looking at a bird on the top of a tree. All right, that's the angle you are making. And that angle of elevation is always at the bottom of your right triangle. That is always elevation. Okay? So we need to find that angle right now. So I'm going to call that angle X, so we don't need to find it. A student, 170 centimeters tall. Do we know where to put the 170? The vertical part, right? And I always get a good chuckle out of this one. Cast the shadow of 170. Shadows. Where are shadows if we went outside right now? On the ground, correct? Shadows are not beaming off your forehead, so they would not be the hypotenuse. I would love to see that shadow beaming off your forehead. All right, so it's shadows are on the ground, 170. Got that, Maddie? You ever seen one beaming off your forehead? That would be kind of odd, yes. All right, so we're still going to use sine, cosine, and tangent. So across, what do you got for me? Here's x, this side, opposite, adjacent, hypotenuse. What do you have? Opposite. And how about the other 170 on the ground for your shadow? Adjacent, here we go. Take a look up top. What's attached? O and A. Tangent, all right. So help me, at least just help me set up the equation. You told me it was tangent. What angle are we going from now? It was 37 in the last one. This one? X equals opposite. $170 over adjacent. All right, now we got to stop and talk. And some of you can dig deep and remember this from 2 years ago. Because I'm not going to use the tangent button here. Anybody remember when you had to find an angle, what needed to happen? Darn right you do, Alex. What? Yes, the inverse button, the second button on your calculator. Second tangent. We remember that? Second, anytime you need to find an angle. Let me repeat that. Anytime you need to find an angle, you're going to use the inverse button. So I'm going to say x equals tangent to the -1, 170 over 170. And that angle of elevation, 45 degrees. Questions from you guys? Do letter D for me, please. See if you can do letter D in your groups. Letter D. See if you can get the diagram correct and figure out what to use. Letter D.